Okay, so if our function is x cubed, our inverse function, exchange x and y, solve for y, our inverse function is cube root of x. Remember function composition. Tell me, what is f composed of f inverse x? Well, function composition is just substitution. We're going to have f acting on f inverse. Composition is substitution. What's f inverse? Cube root x. So f acts on the cube root of x. What does f do to its input? It cubes it. So this would be the input cubed. What am I putting in? The cube root of x. And if I cube the cube root of x, what do I get? X. Every time you compose a function with its inverse, you will get x. Every time you compose an inverse with a function, you will get x. If you don't, it's not the inverse. Okay, so it's a really important concept. A function composed of its inverse is x. How come? Well, because the inverse just undid whatever the function was doing. Okay, so if I was cubing it, and now I cube root it, well, I just get back to my input. Okay, so let's take that and look at some specific numerical examples. If the function at 1 is 5, and the function at 3 is 7, and the function at 8 is negative 10, what's the inverse at 7? Well, this particular function has this in its domain. Let me do a cloud diagram for you. It took 1 over 2, 5 in the range. It took 3 over 2, 7, and it took 8 over 2, negative 10. Okay, the function does that. What does the inverse do? Well, the inverse will undo what the function did. It takes 7 to 3. The inverse undoes what the function just did. That is, it's going to take 5 back to 1. What happens to negative 10? You get 8. So for the inverse, the domain becomes the old range. The range becomes the old domain. Okay, so when we say this, f inverse x equals y, it means the function at y equals x. If I take an inverse and compose the function, I get x. If I take function and compose it with inverse, I get x. If this doesn't happen, you don't have the inverse. How do we find an inverse of a function? I think in Math 12 we did the order a little bit differently. It doesn't really matter, but we write y equals f at x, and then we interchanged x and y and then solved for y. I think in your textbook they take y equals f at x and they solve it for y and then they exchange it. It doesn't matter which order you do that in. Let's do a little bit of practice. Can you find the inverse of this function? So we're going to start out writing y equals x cubed plus 2. If I'm finding the inverse, I exchange x and y. That is, x equals y cubed plus 2. And then I solve it for y. Subtract 2 from both sides. Isolate the y by taking the cube root of both sides, and I get y equals the cube root of x minus 2. So what is the inverse function? F inverse x is equal to cube root x minus 2. Let's go back to the original function, this one right here. What's the domain for a cubic? And the range for a cubic? All reals. The inverse function, cube root, what's the domain? And the range? All reals. Right, you can take the cube root of a negative. Okay, graphically or visually, remember that when you're taking the inverse, you are reflecting it over the line y equals x. Let's graph this function and its inverse on the same grid. So before I start, I'm going to write this radical function in preferred format, factoring out that -1. Because I know what this function y equals root x looks like. It looks like this. Okay, from your catalog of basic functions in Math 12, there's root x. What kind of transformations do I have? Well, x goes to -x, meaning I've got a reflection in the y-axis, aka I'm flipping that backwards. And that +1, remember we had to factor out the leading coefficient, is saying that this moves 1 to the left. So I'm going to flip this backwards and move it 1 to the left. So instead of looking like this, it's going to look like that. And 1 to the left, it starts here. And then this one would go over here. And then this one, where it would be -1, 2, 3, 4, and 1 to the left. So this function would look like this. Okay, so here is f at x. What does the inverse look like? So I'm not asking you to find the inverse, I'm just asking you to graph the inverse. When you graph the inverse, you exchange x and y. So this point, -1, 0, becomes the point 0, -1. This point, -2, 1, becomes the point 1, -2. This point, 1, 2, 3, 4, 5, -5, 2 becomes the point 2, -1, 2, 3, 4, 5. So it's going to look like that. Remember we took this and we reflected that green function across the line y equals x.